Good evening. Welcome to the Advanced Green Manufacturing Systems course, and today we are going to discuss the topic called modeling, and I am Dr. Deepu Phule from IIT Kanpur, and today is lecture. The learning agenda of today's class is we look the basics of optimization, and this, remember, this is important because this is a new topic for many students, and most of the green manufacturing courses does not cover this concept of optimization, because optimization is important for us, and how to realize green manufacturing through optimization. So that aspect is taken care of by this part of basics of optimization. Then we will work an example, okay, modeling through an example. So example to help in understanding the mechanics of optimization, okay, and then a few rules of modeling which is there to us, guidelines to realize proper optimization models or reduce modeling pitfalls, okay. So these three are the major aspects of today's lecture. We study the basics of optimization, we work out an example, and then from there we derive the rules for modeling, okay. So let's talk about the overview of optimization. What is optimization and what is the major aspects of optimization? So the simple definition, or we can call it as the working definition, okay. The working definition in this regard is this, very simple, okay. Solving real world problems via optimization models okay. So optimization means solving real life problems, okay, solving real world problems using optimization models, okay, and this is a two-step process, okay. This solving or the real world problems using optimization models is a two-step process. Number one, the first step is constructing an appropriate optimization model, construct an appropriate optimization model of the real world problem, So the first step is constructing an appropriate optimization model. Appropriate means the model that is relevant, okay. The appropriateness can also be, think about as the relevance of the real world problem. And then the second part of it is solving the optimization model, in order to solve the real world problem. So the second step is you solve the optimization model, which is the approximation of the real world problem, and then once you solve this one, you will actually end up solving the real world problem, okay. And so that's what is called as an optimization. So optimization in a way is that you solve the real world problem by solving the optimization model. And what's an optimization model? It is actually an approximation or an abstraction. So when somebody says model, okay, I usually tell model is an abstraction of a system, okay. for any system in that regard. In our case, we are looking at the manufacturing systems, so we will be building models. So what we are actually trying to do is we look at, in our current class, it will be manufacturing systems. Okay, this is what the real world is, real world, and we abstract, or the process of abstraction, and we create relevant models. Okay, and then we optimize these models for achieving green manufacturing. Okay, so when you make these models green, these relevant models, when you convert them to green manufacturing models, so then what happens is, when these models become green models, okay, these green models, this real system will become green manufacturing. That is the idea here. Okay, so by solving the model, we will actually be able to do this. Okay, and the question is also, other thing that you need to understand is, A, models are usually constructed by hand, or what we call it as individual. The individual usually constructs the model, okay, or builds the model. The second part you need to think about is model solving. Model solving typically requires a computer. Okay, so the solving of the model requires a computer. So in this case, when you abstract this portion, this building, okay, of the model, you require an individual. The optimization of this is the solving, okay, you require a computer in this regard. Okay, so that is the idea in this regard. And once you optimize this, when you solve this, then the green model will result in what we call as a green manufacturing system. Okay, so the idea here is, this whole concept of this optimization is all about that. It's a two-step process, as I said. You construct an appropriate optimization model, or as I said earlier, model is an abstraction of the system of the real world problem, and then you optimize this model in order to solve the real world problem. Okay, so that is the idea in this case, and models are usually built by hand. You construct the model by hand, and the model solving is typically done with the help of a computer. All right. So then let's talk about the major components of the optimization, or major aspects or components of optimization. Okay, so there are three main components of an components in an optimization model. Optimization model. There are three major components in an optimization model. So the first component includes, so the first one we call it as variables. Okay, variables are the first component of the optimization models, and variables, these represent model components, or components of the model components that can be changed, okay, to create, okay, or emulate different options, okay, or what we call as possibilities, or a better term for it as alternatives. Okay, so the first part of this whole thing is what we call as variables. So variables are the components of the model, or model components, that can be changed, or you could change the value of them. Okay, that can be changed, the values of that can be changed to create or emulate different options or different alternatives. So when you want to, so the variables are the ones that you can actually modify or change them to create different alternatives that can be evaluated. So that is the first part of a optimization model. Second one is what we call as constraints. Okay, constraints are, these represent limitations on the variable, limitations or restrictions on the variable. Okay. So an example of this is, so when you say limitations or restrictions, an example, I'll give you a simple example so that it makes sense to you. If the variable is fuel efficiency, okay, so then which implies value should be greater than 0. Ideally speaking, the value should be greater than 0. You cannot have a negative fuel efficiency, ideally speaking, right? Maybe the way you look into it, but the idea is that the worst fuel efficiency you can think about is very close to 0. Okay, right. So that's one example. Third case is, third aspect. So the constraints is, they are the limitations on the variable. So what are the values the variable can take? What is the maximum value the variable can take? Those kind of things are all part of the constraints. Then the last part is the objective function. Many of you might have heard about this term, objective function, like this. The objective function, what it does is, this assigns, the objective function assigns a value to each of the different possibility. Okay, so it assigns a value to each of the different possibility and it gets its name from the fact that the objective is to optimize this function. So the idea is that what objective function does is, it assigns a value to each of the different possibilities. So by combination of those different values of the variables and constraints, you assign a value to each of the different possibility of the model, whatever you talked about. And it's called objective function is that this function which assigns this value, the idea is to optimize this function. So the objective function is something that you optimize, so that these variables, so that way the optimized objective function will provide the optimal values of the variables of the variable or the variables. So the variables, once you optimize the objective function, then the resulting values, the assigned values of the option, that possibility that you picked up or the alternative that you picked up, then whatever the variables that resulted in that alternative, that settings will be the optimal values of that variable. Okay. So in this course the models that we use, okay, the models that are used are mathematical ones or mathematical models. Okay, we are not really talking about building a physical model. Okay. So then these mathematical models are constructed, are developed, let's call it as developed. We develop these models to represent sustainability aspects of sustainability aspects of real world manufacturing systems. So what we are saying is that in this course the models we refer to are mathematical models, and these mathematical models are developed, or we develop them to represent the sustainability aspects, or what we are trying to model is the sustainability aspects of the real world manufacturing system. Okay. So now with this, what we will do is, with this understanding of the components of optimization, let us get into a simple example of this problem. Okay. And what I am trying to, well, let's think about a scenario where a student, a prospective college student, okay, from Kanpur, this city of Kanpur, is planning to visit campuses of 3 colleges in India: Bombay, Delhi and Madras. Let's assume that a student from Kanpur is going to visit IIT Bombay, IIT Delhi and IIT Madras on an extended trip, starting from and returning to Kanpur. So you are starting and returning to Kanpur. So starting from Kanpur, then going and visiting Bombay, Delhi and Madras. Okay, and you are visiting the college campuses. So you are visiting 3 cities. Okay, starting from Kanpur. And the student, what he wants to do? He wants to visit each college only once. So you have to visit the city only once while making the round trip. So round trip means you start from Kanpur, okay, then you visit city 1, then city 2 and city 3, and then you come back to Kanpur. This is the idea. Okay, and the aim is you want to make it as cheap as possible. Okay, make it the cost, how much ever the cost associated with doing this, starting from Kanpur, traveling to 3 different cities, Bombay, Delhi and Madras, and come back to Kanpur in the cheapest possible. The cost of it should be cheapest possible. Okay, the traveling cost, the cost of traveling between these cities are given below. Okay, so what does this say is, you can think about this as a matrix. You can think about it as something like this. This is from and to. Okay, so when we say this, we can say this is Kanpur to Kanpur, the cost is 0. That means ideally you don't want to travel between Kanpur to Kanpur, and even though we joke about this in Kanpur, this 2,600 rupees, whatever it is, units, rupees, dollars, yen, doesn't matter. This is the cost of traveling from Kanpur to Delhi. This 3,400 is the cost of traveling from Kanpur to Bombay. 7,800 is the cost of traveling from Kanpur to Madras. So this 7,800 is true when you see here. This is the cost of traveling coming back to Kanpur from Madras, 7,800. So if it takes same amount that way, so these values are exactly the mirrored. So this matrix, if you think about it, you can actually think about this cost is literally mirrored in this side. Okay, when you say 3,400, that means it's the cost of coming back to Kanpur from Mumbai. 2,600 is the cost of coming back from Delhi to Kanpur, like that. Okay, so this 1,800 represents the cost of traveling from Delhi to Bombay. 5,200 is the cost of traveling from Delhi to Madras, and 5,100 is the cost of traveling from Bombay to Madras. And the similar cost, this 5,100 is the cost of traveling from Madras to Bombay, the reverse of it, right? Because you can visit the cities in any different order. We are not really said which order you want to visit. Okay, so this is the setting of the problem, and this is an optimization problem. So we are trying to work this numerical example in such a way that you will understand, and you will understand the different aspects of what are the variables, what are the constraints, and what is the objective function. Okay, so this aim of this example once again is to demonstrate, okay, is to familiarize with variables, constraints and objective function. Okay, and objective function. These 3 aspects of the optimization I want you guys to familiarize with. For this, we are using a simple example of a prospective college student from Kanpur visiting 3 other college campuses in India, which are in Bombay, Delhi and Madras, and the trip starts from Kanpur and it has to end back at Kanpur. Okay, it's a round trip, and the student wants to visit each college only once. So the main aim is to visit the city only once, not multiple times, while making the round trip as cheap as possible. Okay, So you want to reduce the cost of travel as much as possible, and the cost of travel between the cities is given in a matrix, where I said that it's a from to matrix. So since it's a upper part of the matrix actually tells the cost of traveling from different one city to another, and the lower part of the matrix will tell you the cost of traveling from the other city, the reverse side. Okay, so since it's a round trip, so you can have an example of, okay, you can travel, one would be Kanpur to Delhi to Madras to Bombay to Kanpur. Okay, so this is what we call as a round trip. The trip should start at Kanpur and end at Kanpur. So this is the starting point of the trip, this is the ending point of the trip. Okay, so once, and like for another option on this can be Kanpur, it can be Madras, okay, and Delhi and Bombay. This is also another option, right? So in this case, the Delhi Madras, we would use Delhi Madras, this as the price for this case. So we call it as 1, okay, and this Madras Delhi, we can think about this is Madras Delhi, you can call this as 2, and the 2 will be used as the cost there. In this case, these costs are exactly the same, but there could be scenarios where this cost could also be different. So that traveling to from one city to other city can be much more cheaper in one direction or other. But since none of you have an exposure to the optimization aspects of the problem, it is better that we start with such a simple problem to begin with, and then proceed step by step to going through the 3 aspects: the variables, the constraints, and the objective function of the optimization model. And thank you for your patient listening. Good luck.